Hi, welcome to Technical and Engineering Academy. This is Blessed Elvis. Okay, so first of all, before we go into answering questions on eigenvectors and eigenvalues, there is a standard way of writing the matrices, because we are going to begin with matrices. So the matrix in this case is written in form where we have m minus pi I equals to 0, where m is the matrix that has been given in the question. So whatever matrix you have been given, you replace it where there is m, and then I is a matrix of the standard form where we have 1 0 and then 0 1 here. So this is always a standard form of I. So whatever matrix you have been given, you just replace it here, and then you replace where there is I with with this matrix here. So let's look at an example. But before we do that, one thing we should get in mind is that before you answer eigenvectors, you always answer first the eigenvalues. So you may just directly be asked to find eigenvectors. In that case, you should first find the eigenvalues. So let's say you have been given an example where you have been asked to find the eigenvalues of the vector, where you have, let's say, 6, 2, -3, and 1 here. So the first thing that we should do here is to express this given matrix into into the standard form. So remember, the standard form is where we have m minus pi I equals to equals to 0. So in this case, where there is m matrix, I will replace with the vector that I am given. So the vector that I am given, or rather the matrix that I'm given, is 6, 2, -3, 1, minus, as the symbol is here, pi, and then the standard form of I, remember, is 1 0 0 1. So this has to be memorized, so make sure that you know that. Okay, so let's simplify this. We know here we have 6, 2, -3, and 1. Then we are subtracting, so let's multiply this pi here throughout the matrix. So pi multiplied by 1, we are going to have pi. Then pi multiplied by multiplied by 0, we are going to have 0. Then pi multiplied by 0 here, we are going to have 0. Then pi multiplied by 1, we are going to have pi. So all of this equals to equals to 0. So let's just create space here, since we don't need this anymore. Okay, so make sure that you follow up whatever we are doing here. Okay, so here we can simplify. Okay, let's just also grab this part here for the sake of not being confused. Okay, so here we have two matrices. We have the first matrix is 6 2, then -3 1. We are subtracting pi, 0, and then 0 pi. Now, according to the matrix rule, when you are subtracting the given matrices, you subtract according to the position at which that particular value is. So in this case, to express this as a single matrix, we are going to subtract according to the according to the operation that is here, which is subtraction. So we are going to subtract 6 minus pi according to the position. So 6 is here, and at this side here we have pi. So we are going to subtract 6 minus pi, and then according to this position here, we are going to subtract -3 and 0. So we are going to have -3 minus 0. According to the position we have here, it's 2, and then subtract this 0. So we are going to have 2 minus 0. And again, here we have 1 minus pi. So it's going to be 1 minus pi equals to equals to 0. So in this case, our main aim is to find the value of of pi. When you find the value of pi, then it means we have found the eigenvalues. So let's simplify this. So here, this is the same as 6, subtract pi, and then -3 minus 0, it's -3, and then 2 minus 0, it's just 2, then 1 minus pi it's just 1 minus pi. We don't know this value. So this equals to what? Equals to 0. Or let me just write this properly. This equals to 0. So let's wrap the top part here. Hopefully you are writing somewhere so that you follow up whatever we are doing here. Okay, now when you have this vector, what do you think we can do for us to find the value of pi? Okay, so for us to find this value of pi, what we have to do is find the determinant. So to find the determinant, you always multiply the major diagonal and then subtract the what? The minor diagonal. So in this case, our major diagonal are what? Our major diagonal are, this is the vector of this nature. So let's just borrow a concept from here for us to determine the determinant. So let's say we have B, C, and D. So to find the determinant of this, what we do always is to multiply A multiplied by D. So the values that are in A and D, you multiply them, and then you subtract the values that are in what? In B and D, C. Then whatever you have after you have found the values here, that's your determinant. So borrowing this same concept, we can use it even on our matrix that we have for us to determine the determinant. So let's do that. So to find the determinant of this, we know now that the major diagonal is 6 minus what? 6 minus pi. We multiply it with what? With 1 minus pi. So all of these, we subtract what? 2 multiplied by negative 3. All of this equal to 0. So here we have a quadratic equation. Okay, so what are we going to do here? Okay, let's just wrap this, because this seems to be quite long and this might disturb. So here we know that to simplify this given expression here, or to expand it, we are going to multiply 6 multiplied by 1. Of course it's 6, and then this same 6 multiplied by negative pi, it's 6, negative 6 pi, and then negative pi multiplied by 1, it's negative pi, and then positive multiplied by, negative multiplied by negative is positive, and then pi multiplied by pi, it's what? Pi squared. Okay, so this is the equation we have, and then here negative multiplied by negative, it's positive, and then 2 multiplied by 3, it's what? It's 6, equals to 0. Okay, so in this case then, we know that we can simplify this further, where we add this 6 plus this 6, we are going to have what? We are going to have 12, and then minus this here, and then we subtract this, we are going to have what? 7 pi, and then plus pi squared equals to 0. So let's rearrange this. Okay, let's just create space so that we can rearrange on top here. From the top, I think down there we might not have enough space. Okay, hopefully you are following. So what we have is what we call a quadratic equation. So since it's a quadratic equation, we are going to solve this quadratically. So whatever method you can use for you to answer this question, it's okay. So here we have pi squared, and then minus 7 pi, and then plus 12, equals to what? Equals to 0. So which method do you think we can use for us to find the values of pi? So whichever method you are comfortable with, you can use. If you are comfortable to use the square method, you can use. If you are comfortable to use the formula method, you can use. If you are also comfortable to use the factorization method, you can use. So in this video, I am going to use factorization method, where we find the product, the sum, and the factors. So the product is the coefficient of pi squared and the constant value, which is 12. So when we multiply the coefficient of pi squared, which you know is 1, there is no value here, so it means there is just 1. So 1 multiplied by 12, we have 12 as our product. And then sum are the values you can add for you to have what? To have negative 7. So in this case, our value is negative 7. It's not always mandatory that the value you should have for the sum is negative 7. Okay, in short, you simply get the value that's here. So the value that's here is what? Negative 7. And then the factors are the values that you can find in such that when you multiply them, you are going to have the what? The product, and then when you add them, you are going to have the sum. So which values do you think we can add for us to have negative 7? And then if we multiply the same values, we are going to have 12. Okay, so if we think of that properly, that is negative 4, and negative 3. Because when we multiply negative 4 and negative 3, we are going to have 12. When we add negative 4 minus 3, we are going to have what? Negative 7. So we have found our factors. Now these factors have to be replaced where there is these values here. So after you have found the factors, you replace them where there is this. So in this case, we are going to have what? Pi squared and then negative 4. You always add the coefficient that is present in the expression. Then negative 3 pi, then plus 12 equals to what? Equals to 0. So we know that pi is common here and here also. So we can factorize pi. So here we have pi minus what? Minus 4. And then minus, which value do you think is common here? It's 3. Of course, 3 can go into 3 and 3 can go also into what? Into 12. So 3 into 3 is just 1. So here we just remain with pi. Then negative multiplied by positive, we have what? We have negative. Then 3 into 12 goes how many times? 4 times. Okay, equals to 0. So when you look at this and that, we have the same factors. So you simply write on one of the two. So we have pi minus 4. And then outside the brackets here, we have pi and also negative 3. So you also write them down. So we have these. So this equals to what? Equals to 0. Okay. So let's just create space here, since now we have our simplified expression. So you can even go ahead and find the answer for that, so that you may move at the same pace. Okay. So now we have this factor and this factor, all of these equated to 0. So we can solve them separately. So we have pi minus 4 equals to 0, and also pi minus 3 equals to 0. Okay, so when we take negative 4 to the other side, of course it will become what? Positive 4. And also when we take 3 to the other side, it will become what? Positive 3. So these are our eigenvectors. This is how we find the eigenvectors whenever you have been given the values. Okay, let's look at one last example on eigenvalues. What of this one? So you may even try it to see if you have gotten the concept. So we have, let's say 3, we have 2 here, and then we have 4 and 1. So you may even go ahead and try it out. You may pause the video, you try it out, and then you check if you are understanding. Okay, so if you are following properly, you always write this in this matrix form. I equals to what? Equals to 0. So our matrix in this case will be what? Okay, will be 3, 2, 4, and 1. Then we subtract what? Pi. Okay, then here we have 1, 0, 0, 1. All of these equal to what? Equal to 0. So in this case, we can multiply this pi throughout in here. Okay, let's see what we've got. So here we have 3, 2, 4, 1. Then subtract pi. So pi multiplied by 1, we are going to have pi. Pi multiplied by 0, we are going to have 0. Pi multiplied by 0, you are going to have 0. Pi multiplied by 1, you are going to have what? Pi. Okay, so hopefully you are able to see here. So we have all these equated to 0. Let's just create space in this case. So this is the first step when it comes to answering the eigenvalues. You first express in that standard matrix. After you have expressed in that standard matrix, you simplify. After you simplify, you find the what? You find the determinant, and then after you find the determinant, you find the values of the pi's. Then that's it. So in this case, we have what? Let me just write properly, since here we can see it well. So we have 3, 2, 4, 1, minus, here we have what? It's pi here, and then we have 0, 0, pi. All of these equal to 0. So let me just delete what we have here, since I have just rewritten them up there, so we can create space. Okay, if you remember, what did we do here? You subtract, you simplify this these matrices. So you subtract according to the position. So these 3 we will subtract what? Pi. So 3 minus pi, since the position implies that we do that. Then also 4 minus what? Minus 0. So 4 minus 0. And also 2 minus what? Minus 0. So of course 2 minus 0. And also 1 minus what? Pi. So 1 minus pi. All of this goes to what? Goes to 0. So we can simplify this further also. So here we don't know the value of pi. Then 4 minus 0, we have 4. 2 subtract 0, it's 2. And then 1 subtract pi, we have 1 subtract pi. We don't know what pi is, so we can't simplify this. So now we have a matrix in this form. After you have done this, what do you do next if you are able to remember from what you have done? Okay, so after you are done with what you have done here, you simply find the determinant. How? We have already discussed that. So you multiply the major diagonal, that is this. So here we have 3 minus pi, and then you multiply with what? Multiply with 1 minus pi. So you always multiply the values that are here, and then you subtract with the values that are in here. So in this case, subtract the values that are what? In that case, we have what? 2 multiplied by 4. All of these equal to what? Equal to 0. Okay, so in this case then, what is 3 multiplied by 1? It's just 3. What is 3 multiplied by pi? It's just 3 pi. We have a negative here, that's why I've written the negative there. So what is pi multiplied by 1? So it's negative pi, since we have a negative sign here. What is pi multiplied by pi? We have what? Pi squared. Now in this case it's going to be positive, because negative multiplied by negative, it's positive. And then we come here, so here we have minus here, and then we multiply 2 multiplied by 4, we have what? 8 equals to 0. So let me just create space down there. Okay, so we may even go ahead and finish it up. Since we have done one example, we are just repeating the same thing. So when we add these 3 with 8, what are we going to have? Of course, we are going to have negative 5. And then here, when we add these, we are going to have what? Negative 4 pi. And then we have positive pi squared equals to 0. So let's write this in standard form of the quadratic equations. So the standard form of the quadratic equations is what? Pi squared minus 4 pi, then minus what? Minus 5 equals to 0. So since we have this expression, we have to solve it quadratically. Remember, our main aim here is to find the values of pi. When you find the value of pi, then that's it. Okay, so let's try to do that. Let's find the value of pi. So if you want, you can go ahead. So this is a quadratic equation. So which formula do you think we can use? Okay, like I said, in this case, I will use the factorization method. So I said before that you can use whatever method you are comfortable with. So in this case, our product will be the coefficient of pi squared with what? The constant here. So in this case, we are going to have the coefficient of pi squared is just 1, and then the constant we have is negative 5. So negative 5 multiplied by constant 1, or rather coefficient 1 of pi squared is just negative 5. So we have negative 5, and then the sum is just the value that's here. So in this case, we have what? Negative 4. Now, on the factors, you have to find the numbers which you can multiply for you to have negative 5, and then when you add the same numbers, you have what? You have negative 4. So what are those numbers? Okay, so the numbers are negative 5 and 1. because when you multiply negative 5 with 1, you are going to have what? Negative 5. When you add negative 5 to 1, you are going to have what? Negative 4. So let's replace in the expression here. So we have pi squared. So these factors, we will replace them where? We will replace them here where we have negative 4 pi. So here we have negative 5 pi. You also include the coefficient that is present. Okay, so here we have just positive here, positive 1. Now remember, this is with respect to what? With pi. So in this case, we are going to just write instead pi, since pi is just the same as 1. So here we have negative 5 equals to what? Equals to 0. So when you see properly, here we have pi, which is common. So you are going to write pi outside the brackets. When you remove 1 pi here, you are going to remain with y pi. Okay, here when you remove pi, you are going to have what? 5, and then positive. Here what is common? There is nothing that is common. So we can simply say just 1. And then we have pi minus what? 5 equals to 0. Okay, if you see properly, you have the common factors here. So you can just write one of the factors in brackets, and then you write the values that you have outside the brackets. That is pi plus what? Plus 1. Okay, all of this equals to 0. So there are a lot of things here. Let's just grab some things which are not necessary. Okay, let's hopefully you are following. So here we have two expressions which we can of course solve separately. So we have pi minus 5 equals to 0. We also have pi plus 1 equals to 0. So in this case then, when we take negative 5 to the other side, we are going to have pi equals to positive 5. When we take positive 1 to the other side, you are going to have pi equals to what? Negative 1. So these are our eigenvalues. So this is how you find the eigenvalues when you have been given a question. Whatever question you have been given, this is how you always find the eigenvalues. Now let's go into eigenvectors. So like I said earlier, you cannot find the eigenvectors without finding the eigenvalues first. So let's do that. So let's say in this case you have been given a equals to, let's say a equals to 1. Let's say we have 4, and then we have 1, 1. So what do you think we should do here next? So having learned what we have learned, go ahead and try to find the eigenvalues first for this expression. So always remember to express in the form m minus pi I equals to what? Equals to 0. Okay, equals to 0. We have already learned this. So where there is matrix, we are going to replace what? 1, 4, 1, 1. And then we subtract what? Pi. Okay, remember always our I was what? 1, 0, 0, 1. Okay, equals to 0. So in this case, we can simplify this further. So here we have 1, 4, and then we have 1, 1, minus. So when we multiply pi with 1 here, we are going to have pi. When we multiply pi with 0 here, we are going to have 0. When we multiply pi with 0 here, we are going to have 0. When you multiply pi with 1, we are going to have what? Pi. All of this equals to what? Equals to 0. So let's simplify this further. Okay, you can go ahead of me so that you may catch me whenever I make a mistake. Of course, I am a human being. Do you believe I can do that? Yeah, of course, it's normal I can. So in this case, then let's simplify this further. Now, remember, we always subtract according to the position. So you subtract 1 with pi here. Remember, we have minus, so it's 1 minus pi. So 1 minus pi. We have that. Then you have 1 minus 0. So it's 1 minus 0. Then you have 4 minus 0. So it's 4 minus 0. Then you have 1 minus pi. And then you have 1 minus pi. All of these equal to what? Equal to 0. So let's also simplify this further. Of course, we know that we can have, okay, in this case, this will just come out the way it is. And then 1, we subtract 0, we are going to have what? 1. And then 4, we subtract 0, we are going to have what? 4. Then 1 minus pi is just 1 minus pi. okay, equals to 0. So let's wrap this to make space here so that we can work properly. So by now you understand how this is all about. So we can find the determinant. So we can go ahead now. So this multiplied by that, of course we know by now that's 1 minus pi multiplied by 1 minus what? Pi. All of these we subtract with what? With 4 multiplied by 1 equal to what? Equal to 0. So in this case, let's just write this on top here for the sake of space, as it might not fit down there. Okay. So in this case then, we are going to have 1 multiplied by 1, of course it's just 1. 1 multiplied by pi, of course it's just pi. And then pi multiplied by 1, of course it's pi. And then pi multiplied by pi, negative multiplied by negative, it's positive, so it's positive what? Pi squared. Then we subtract here, minus 4 multiplied by 1, it's just 4, equal to 0. So let's simplify this. So we know that 1 subtracted negative 4, we are going to have negative 3. And then negative pi minus pi, we are going to have negative 2 pi. And then we have positive pi squared equal to 0. So let's just create space down there. Okay. So let's write in quadratic standard form. So writing this in quadratic standard form, we have pi squared minus 2 pi and then minus 3 equal to what? Equal to 0. So likewise, I will find the product, the sum, and then also the factors. So the product here is what? Is negative 3. And then the sum is what? Negative 2. So what values do you think we can multiply to have negative 3? And then when we add the same values, we have negative 2. Of course, it's negative 3, comma what? Comma 1. So these are the values that we are going to replace here. Okay, so we have what? Pi squared. Then subtract 3 pi. And then we add what? We add pi. Okay, and then minus 3 equals to what? Equals to 0. So let's just create space here. Okay, let's just create space. Let's just create space. So hopefully you are following and you have tried this on your own. You are just trying to confirm what this is all about. So pi here we have is common, so we write it outside the brackets. So when you move 1 pi here, we are going to remain with pi, and then minus, when you move pi here, we are going to have what? 3. Okay, and then plus. In this case, there is nothing that is common, so it's just 1. Okay. So here we remain with what? With pi minus 3 equal to 0. So if you check, this and that have the same what? Common factors. So we are going to write one of the two. And then we write the values that are outside the brackets. So that is pi plus 1 equal to what? Equal to 0. So let's just find the values of whatever we have here. So we know that we have two values. The first one is where we have pi minus 3 equal to 0, and the other one is where we have pi plus 1 equal to what? Equal to 0. So in this case we have pi equals to 3 when negative 3 goes to the other side. We also have pi equals to negative 1 when positive 1 goes to the other side. So we have two values of what? Of pi here. So these are what? These are what we call the eigenvalues. Now remember, our main aim is to find what? The eigenvectors. Okay, so we have two values of, so we have two values of pi here. Okay, so let's deal with this when pi equals to 3. Okay, let me just reduce the font here. So when pi equals to 3, remember we have two values, so let's just first begin with this one. Now, there is one thing that we should understand when it comes to writing the eigenvectors. We always add x. So then the standard matrix becomes m, pi, I, then x here equals to 0. So this x is the eigenvector. Okay, so this eigenvector, of course, can represent values, let's say x1 with x2. This mostly is for the matrices which are 2 by 2. Then for 3 by 3, you go as far as x3. So in this case, we are just going to end with x2 since we are dealing with a 2 by 2 matrix. So remember what you had in the first place. In the first place, we had 4, 1, 1, 1 here, and then we had pi minus what? Okay, it was not subtraction here. We had 0, also pi, and then 0 here. All these were equated to 0. So after we had simplified this, we had 4 minus pi. Then here we had 1. Also here we add 1, and then here we add 1 minus pi. Okay, equals to what? Equals to 0. Now we have added the vector for x here. So in this case then, what will this turn out to be? So let's just create space here so that we can see how this is going to be. Okay, so for the eigenvectors, remember for the eigenvectors, you always add this vector here. So in this case, this will be 4, subtract pi, then 1 here, 1, then 1, subtract pi. Then we are going to add the vector here, which is x1 and also x2. All of these equal to what? Equal to 0. So in this case, remember we have said let our pi firstly equal to what? Equal to 3. So wherever there is pi in this expression, we are going to replace with 3. We are going to replace with 3. Okay, since we have the value in this case. So we are going to have 4 minus 3, and then 1, 1, 1, minus what? Minus 3. Remember here we have what? x1 and x2. Okay, equals to 0. So in this case, we can simplify this further. So what is 4 subtract 3? It's 1. Down there we have 1. Top here we have 1. Then what is 1 subtract 3? It's negative 2. Okay, and then here we have our x1 and then also our x2. So remember, our main aim is to find the value of x1 and x2. When we find these values, then those values are what? Are the eigenvectors. So let's create space on top here so that we can see how this works out. So hopefully you are also following. So in this case now we have this as our vector. Now according to the vector rule, you always deal with the rows by column. So in this case we are going to first multiply 1 multiplied by x1, it's what? It's x1 plus what is x? What is 1 multiplied by x2? It's just x2. Okay, all these equal to what? Equal to 0. Then what is 1 multiplied by x1? It's just x1. Then what is here we always add, what is negative 2 multiplied by x2? It's negative 2x2. Okay, so in this case we have this can also be written as x1 plus x2 equal to what? Equal to 0. And then here we have x1, positive and negative, positive here and negative here, we have negative 2x2. So in this case then, we can, let's try to rub here. Okay, let's try to rub so that we have enough space for us to simplify this as much further as we can. Okay, so in this case then, we have that the top part is x1 equal to x2. We also have the down part as x1. Here it's x1 equal to, sorry, this is not the case. It has to be x1 plus x2 equal to 0. And then down there we have x1 minus 2x2 equal to what? Equal to 0. Okay, so in this case, let's try to wrap this, since we don't need this information now. So in this case, then we can, of course, on top here, we can say x equal to negative x2 when x2 goes to the other side. And this down here, we can have x1 equal to what? Equal to positive x2. Now, our main aim is to make sure that whenever we will replace the values here, our value will not give a fraction. If you want, you can solve this. If you can solve this easily, where there is x1, we replace with x2, and then solve this expression. However, the simpler way of answering this question is by assuming. Let's say where there is x2, we replace with 1 here. What are we going to have? Where there is x2, we replace with 1. What will be our x1? Of course, when we replace where there is x2 with 1, we are going to have 2 multiplied by 1. And what is 2 multiplied by 1? It's 2. So these are the values. Okay, so this is the one method. The other method by which we can use, instead of doing what you have done, is by replacing where there is x1 with negative x, since this implies that where there is x1, there is this value. It's also going to give the value. So in this case, remember our eigenvector was what? Was x1, and then here we had x2. So we are going to replace whenever there is x1 with the value that we have found, and whenever there is x2 with the value that we have found. So in this case then, how is it going to be? So our eigenvector then will be, where there is x1, we have found that there is what? There is 2. And where there is x2, there is what? There is 1. So we have, so this is our eigenvector when, not x, when of course pi is 3. Okay, now remember we had 2 pi, we had even pi equals to negative 1. So you may also try when pi equals to negative 1. So let's do that. So if pi equals to negative 1, remember we had what? 4 minus pi, 1 here, we had 1 minus pi, and then here we have what? x1 and x2 equal to what? Equal to 0. So our pi is negative 1, so it's 4 minus negative 1, and then we have 1, and then 1 minus negative 1, and then we have x1 here, x2, all of this equal to what? Equal to 0. So let's create space here. Okay, so hopefully you are following, you are not confused. This is the expression that we had at first, the matrix that we had at first when we were finding the eigenvalues. So in this case, of course, we know that we can simplify this. Of course, we know negative and negative here is just positive. Then it becomes 4 plus 1, that's 5. And then down here we have 1, and here we have 1. Then negative and negative is positive. 1 plus 1 is 2 here. Okay, so remember here we have what? We have x1 and also x2 equal to 0. Okay, so let's also get rid of this so that we can create space. So in this case then, how can we simplify this further? So we know that it's this multiplied by this, added to this, multiplied by that. So we are going to have what? 5x1 added to what? 1 multiplied by x2 is just x2 equal to what? Equal to 0. And then down here we have 1 multiplied by x1, just x1 added to 2 multiplied by x2. It's what? It's 2x2 equal to 0. So this is a simultaneous equation. So you can solve this simultaneously, where of course this can come to the other side, so that we can have x2 equal to negative 5 of x1, and also where there is This of course can go to the other side if you want, or you can just make it up from here. So here you can assume, let's say, what if x1 equal to 1? What will be our x2? So our x2 in this case will be what? Will be -5. Okay, so that's it. So remember at first we had eigenvector equals to x1, and then here we had x2. So we have to replace in this case. So where there is x1, we had already found that x1 was 1, and then x2 was what? 5. So this is how you find the eigenvectors. So let's look at one more last example so that we can have a clear picture of what this is. So let's say you have b, the vector, let's say we have 3, -1, and then we also have 5 and -3 here. What do you think we need to do for us to find the eigenvectors? So remember, the first rule is first to find the eigenvalues. So the eigenvalues, by now you understand that this is 3, -1, 5, -3, minus pi, 0, 0, pi, equal to 0. So in this case, simplifying further, we have what? 3 minus pi is 3 minus pi, and then 5 minus 0, and also -1 minus 0, and -3 minus pi. Okay, all of this equal to what? Equal to 0. So we know that we can simplify this further. So let's just create space on top. You can go ahead of me since we have learned all this so that you get the point. So in this case then, we are going to have 3, subtract pi. What is -1 minus 0? It's just -1. What's 5 minus 0? It's just 5. So here we have -3 minus pi. All of these equal to 0. So in this case, let's just create space down here so that we can have as much space as we can. So in this case then, we have this matrix. What was the point? The first point is that we need to find the determinant of this. And remember, the determinant is that you multiply with the major diagonal and subtract the multiplication of the minor diagonal. So the major diagonal we have these values here. So we have looked at this already. So by now I'm sure you are able to manipulate this on your own. So we have -1 multiplied by 5 equals to what? Equal to 0. So we have 3 multiplied by -3, that is -9. And then 3 multiplied by -pi, that is -3 pi. And then -pi multiplied by -3, that is +3 pi. And then -pi multiplied by -pi, we are going to have what? +pi squared. And then negative and negative, we are going to have what? Positive. Then 1 multiplied by 5, it's just 5, equal to what? Equal to 0. So in this case, of course, we know that this and this will cancel. And then here we are going to remain with 5 and -9. So what is -9 added to 5? It's -4. So -4 plus what? Plus pi squared. These are the only values that are remaining in this expression. So let's just create space on top there. So what do you think is the best way of simplifying this expression? How can we find the values of pi since we have such kind of an expression? Well, in this case, of course, this is very simple. All we need to do is take 4 to the other side and then find the square root of the value. So when we take -4 to the other side, we are going to have +4. So if you find the square roots of both sides, the square root of 4, we are going to have here it's pi. What's the square root of 4? Of course, the square root of 4 is just 2 here. So in this case then, we have our eigenvalues as +2 and also -2. So these are the values that we are going to place in our expression for us to find the eigenvectors. So let's do that. So remember, the standard form is M, matrix given, and then pi I, and then eigenvector here, which is this, equal to 0. So now let's begin when pi equals to 2. So in this case then, remember we had, I remember in the previous question, remember we had 3 subtract pi, and then we also had what, 5 subtract 0. We also had what, we had -1 subtract pi. We also had here we had 0 subtract 0. We also had -3 subtract pi, and then here we have x1 x2 for the eigenvectors, and then 0 here. So let's replace. So where there is pi, replace with 2. So it's 3 minus 2, and then 5 minus 0 is just 5, and then -1 minus 0 is just -1, and then -3 here we replace where there is pi with what? With 2. And then we have the vectors, that is x1 and also x2. So all of these equal to what? Equal to 0. So we can subtract, rather we can remove the top part here, since we don't need it, it's not necessary this time. Okay, so we have this. So let's simplify this. So 3 minus 2, that's 1, and then we have 5 here, and we have -1. Then -3, we subtract -2, we have what? -5. Okay, and then remember here we have what? x1 and x2. All of these equal to what? Equal to 0. So again, what do you think we need to do here for us to find the values of x1 and x2? So if you are able to remember, here what we simply do is multiply the rows by column. So we are going to multiply these and then add these. So we are going to have 1 multiplied by x1, just x1, plus what is here we have then 5 multiplied by x2, we are going to have what? 5x2. Okay, in the brackets equal to 0. So we have also -1 multiplied by x1 on top here, we are going to have -x1, and then 5 multiplied by x2, remember there is addition here, so -5x2. So let's simplify this further. So we have x1 plus 5x2, and then here we have -x1, negative and positive is just negative of what? 5x2. All of this equals to what? Equal to 0. So we can equate these expressions to 0. So the top part we have, it's x1 plus 5x2 equal to 0, and the down part we have is -x1 and then minus 5x2. All of this equal to what? Equal to 0. So in this case then we have the two expressions. Now what do you think? Which method can we use to solve this? So even if this is a simultaneous equation, if you use a simultaneous equation, you're going to not find the values of x1 and x2. So what do you think we can do? So here we can use approximation. Let's say x1, when 5 comes, the top part here, when positive 5 comes to the right side, you are going to have -5x2. Then down here, we are going to remain with -x1. When that comes to the other side, it's going to be positive x2. So we can simply assume, let's say if x2 equal to 1, and then we replace here. Of course, in whatever expression we are going to replace, let's say in x1, if we replace where there is x2 with 1, we are going to have that x1 is what? It's 5. Likewise, if we replace where there is -x1, here we replace with what? With 5. We are going to have, sorry, there is a negative here, so this is going to be negative. This is negative here. Let me just, for the sake of understanding, let me just move this. Okay, so here when I So I also remove this. Let me just remove this. Okay, so where there is x1, remember we are assuming that there is 1. So in this case then, there is 1. So negative x1 equals to what? 5 multiplied by 1 is just 5. And then when you multiply this negative 1 throughout, we are going to have what? Here when we multiply with negative 1, even here with negative 1. Of course, this negative and negative will make positive. And then here, we are going to have what? We are going to have negative 5, since this is positive. So in this case, we are going to have that our x1 equals to what? It's equals to negative 5. So I was just trying to prove that whether you use the first expression or you use the second expression, the values will give the same. So you simply assume mostly where x equals to x1, where x equals to 1 does not disappoint. So here when you replace where there is x1, x2 you replace with 1. Of course, we can easily find the other value for x1 here. Where there is x2 replaced with 1, we're going to have this value here. So it's advisable that whenever you are solving such kind of expressions, you first deal with this one, which is more complex. You simplify it. After you simplify it, then this one is going to be simple. Like you can see, where there is x2, we just assume to say let there be 1. If you put 1 here, of course, this is gonna be it's gonna have its own value. So that's how this was. So let's just write here. So our x1 is what? Negative 5, and our x2 is what? It's just 1. So in this case, our eigenvector will be what? Remember, it's x1 and x2 here. So where there is x1, we are going to replace with negative 5, and where there is x2, we are going to replace with what? 1. So this is our eigenvector when pi equals to what? Equal to positive 2. Okay, so try out if pi equals to negative 2. Now remember what we had. So in the first place, we had what? We had 3 minus pi, of course. Okay, let's just write the expression for the sake of not being confused. So here we have 5, and then we have negative 3 minus pi. Okay, and then here we have what? Negative 1. So this was our expression. And here we are adding the eigenvector of x1 and x2. All of this equals to 0. Remember, this time we are saying we are solving this with pi equal to negative 2. So we are going to do that. So where there is pi, we put negative 2. So in this case then, it's going to be 3 minus negative 2. And then here 5, negative 3 minus negative 2. All of these equal to 0. Sorry, there is x1 and x2. So there is x1 and x2. All of these equals to 0. And then here we have negative 1. So in this case then, we can simplify this further. So here we have, what is negative and negative? It's positive. So 3 plus 5, 3 plus 2 rather, it's 5. And then here we have 5 already, then negative 1 here, and then negative 3, negative and negative is positive, so negative 3 with positive 2, we are going to have negative 1 here. Here we have the eigenvectors x1 and x2, all of this equals to what? Equal to 0. So let's create space on top here, so that we might have space to write on. So hopefully you are following. So it's wise that you try this, you finish it up on your own to understand the concept, since we have done something likewise. So in this case, let's simplify this. So we are going to multiply this 5 multiplied by x1. So we are going to have what? We are going to have 5x1. And then this 5 multiplied by x2 is going to be plus 5x2. Okay, all of these in brackets equals to 0. And then this negative 1 with what? With x1, we are going to have what? Negative x1. And then this negative 1 with x2, we are going to have negative of x2. Since here it's positive, and then we multiply with the negative x here. Okay, let's just do that so that we don't get confused at the end of the day. So in this case then, what are we going to have here? We can simplify this. So in this case, we are going to have 5x1 added to 5x2 equal to 0. And then down there we have negative x1. Remember, positive and negative makes what? Negative x2 equal to 0. So we may take these values to the other side. So you can solve this simultaneously. However, it won't give you values. So the best way to do this is just to assume. In this case, it doesn't matter which one you take to the right side. So if you want, you can even simplify this further so that you have what? You have x1 plus x2 equal to 0. And then down there you have negative x1, negative x2 equal to what? Equal to 0. So if you want, you can take the x2 to the other side so that you have negative x what? X2. So let's assume now, how can we solve this expression? Let's assume that x2 equals to negative 1, or rather it equals to 1. So if we say x2 equals to 1, okay, let it be positive, equal to 1. Of course, x1 is going to be what? It's going to be negative 1. Okay, let's try the other way around. What if we replace in the expression where we have negative x1? Of course, when this negative x2 goes to the other side, it's going to be positive x2. So in this case, let's assume our x2, or rather x1 if you want, if x1 goes to 1. So if x1 goes to 1, of course this is going to be positive 1 multiplied by negative, it's going to be negative 1 equals to x2. So it's just one and the same thing. So in this case, then we have that our x1 is going to be 1 and our x2 is going to be what? Negative 1. So in this case, replacing in the eigenvector, we are going to have x1 here and x2 down there. So if we replace these values, we are going to have what? 1 and negative 1. So these are the values. So if you are struggling where I said you just estimate, you simply simplify the expression, okay? You can let it go to n value. Let's say if you say in the expression where we had, where we had x2, let's say you have, let this equal to negative 2. If you replace, of course, you're going to have a proper value. So it does not matter how you simplify this, but mostly you begin with the minimum, with a minimum number. So minimum number that we mostly have is just 1. That's why in this expression we are mostly using 1. So throughout in here we are mostly using 1. So you can use any other value that you are comfortable with. So hopefully that these videos have given you the insight, or rather this video has given you the insight on how to go about this. So remember to find the eigenvector, or rather the eigenvalue, you replace where there is m with this. So let's just give a summary of what this is all about. So this is what we always follow, and then if you are finding the eigenvectors, you always add what? The vector outside the brackets, that's x, equal to what? Equal to 0, where this is the what? The matrix that is given in the expression, and this is what? Okay, this is the vector 1, 0, 0, 1. Remember, when you are looking for the eigenvalues, you are looking for the value of pi. When you are looking for the eigenvector, you are looking for the eigen of the values rather of x, where x vector equals to x1 and x2. So when you find these values, those are your eigenvectors. So hopefully that you have now gotten the concept. Thanks once again, guys, for staying this far. Please like, subscribe, share, and turn on the notification button so that you are updated whenever I upload a new video. Stay blessed.